Hello everyone, welcome back to my channel. In today's video, we are going to solve Leetcode problem number 701, that is insert into a binary search tree. So let's first understand this problem. So we are given the root of a binary search tree and our task is to insert the value into the BST, right? And then we need to return the updated tree. So before jumping into the code, let's quickly recall the BST property. So in binary search tree, every value, right? I'm going to take a pencil. Every value in the left subtree is going to be smaller than the current node, right? And every value in the right subtree is going to be greater than the current node. And this property helps us efficiently search, insert, and delete nodes. So now let's build the intuition. So the insertion process is actually very similar to the searching for a value in a BST. So first, we're going to start from the root node, right? In this case, the root node value is going to be 4, right? Then we're going to compare the value of root node from the value which we need to insert, right? We're going to compare this value or this root value, right? So in this case, the root value is going to be 4 and the value that we need to insert is 5. So we're going to compare it. And as we know, the root value is less than the current or the value that we need to insert, right? So it means we need to move towards the right side as we need to follow the property of BST. So that is why if we're going to insert this value, then obviously then we need to move towards the right side, right? Then we have in right side we have 7, which is greater than the value we need to insert. Means this time we need to move towards the left side, right? As we know, the left side value is less than the root node. It means we're going to make a new node. I'm going to make this a new node, and at the left side of this 7th node, we're going to insert this node, which is going to be this 5. And then we're going to connect this node like this, right? So that's it. The BST property remain valid automatically, right? And now let's move to the coding part. Okay. So firstly, we're going to handle the edge case. So if root is going to be null or if we didn't have a root, so we'll simply make a root, right? So if the tree is empty, so if not root, then what we're going to do, we're going to simply create a new node with the given value and then we're going to return it. So it will be tree, yes, tree node, then we're going to insert that value. Okay, now what we're going to do after that, we're going to create a temporary pointer, right? And I'm going to name them temp, and it will going to point to the root. So we're going to make temp a temporary pointer which will going to point root. And after that, we're going to apply a loop. So I'm going to write a while temp not equals to none, right? The loop continues as long as the temp is not null, right? And inside the loop, we're going to compare the current node value with the insertion value, right? So we're going to compare if temp dot well. This is the current value of our root node, right? We're going to compare with this value that we need to insert, right? Right. If our root node is going to be less than the node that we need to insert, that means we need to move towards the right side, right? So if temp dot, we're also going to check that if the right side value is going to be none, then we know that we get a position and there we're going to insert that. So temp dot right equals to the tree node, and there we're going to insert this value, right? And if that node is not null, then also we're going to break that, right? On the spot, we're going to break, right? Now, if that node is not null, right? So we're going to traverse through the right side. So temp equals to temp dot right. We're going to move towards the right side again. Now, in else case, means our node value is greater than the value that we need to insert. So, we're basically going to move towards the left side, right? So, if temp dot, we're going to again check temp dot left equals to none, means if we didn't have any value at the left side, means it's a correct position, and then we're going to insert this node. So temp dot left equals to, we're going to insert this. I'm going to make this capital. So TRE3 node, there we're going to insert this value, right? And also we're going to break. We don't need to move further. And if we didn't get the null value, then we're going to traverse the left side. So temp equals to temp dot left, right? And at the end, we basically going to return root, that updated root, right? So return root. Now let's run this code. Yes, accepted. And now let's see the dry run of this code. So basically here we have a dry run. Okay. So basically we have a temporary pointer, there we have a root. So we're going to check while temp not equals to null. So in temp we have 4. Right now we have 4, right? So I'm going to write over here in temp we have 4, right? So 4 not equals to null. Then we're going to compare temp dot well less than well. 4 is less than 5. Yes. If it is less than 5, then we're again going to check the condition that temp dot right. So in temp dot right, we have another node which is 7. Means we didn't have a null value, right? Then what we're going to do, we're going to traverse the right side, right? Means this time we get the root node is going to be 7, right? So here we get 7. Now again we're going to check temp is null, so no temp is not null. Then we're going to check if temp dot well, which is 7, is less than 5. No, 7 is not less than 5. Means this condition is getting wrong. Means we're going to move towards this condition. Right? Now, if temp dot left, which is 7, equals to none. Sorry, temp dot left is none, right? We didn't have a left child of this node, right? So temp dot left is none. So what we're going to do, we're going to insert this node at the left side of this seventh node, right? So basically we're going to insert over here, right? And that's how the entire dry run going to be look like. And now let's run this code. um Submitted. So if this explanation helped you to understand binary search insertion, so make sure to like this video and subscribe, and thank you for watching, and I'm going to see you in the next video.